Hello and welcome to this video. In this video, we will learn more about standard library of Python. So this is the 8th part of standard library. So we will resume where we left off in the last video. The first function is memory view. We will not study this right now. We will, when we discuss the memory view class, at that time we will look into memory view function of this. The second function is the min function. So now min function is analogous to the max function, which I have discussed in a previous video, and it behaves in a similar way. So suppose you give it 3 arguments, it takes a list of iterables, or you can take something like a list, or it can take arguments. And if you want to provide more arguments with list, then you have to unpack, or it can take a sequence of lists like this. It can take an empty list, but then you have to provide a default, otherwise a value error will be raised. And similarly, it can take strings as well. So the main function will compute the minimum of all the arguments. So let's see this in action. Python libate.py. Okay, so there is some error in commenting. Oh, did it say Unicode scope can decode by? Okay, there are some Unicode characters here. So we'll have to remove the Unicode characters. Okay, we'll see about that. So I put it here, I guess. Work. Okay, it works now. So the minimum value is 1, 2, 3 between the lists 1, 2, 3 and 1, 3, 5. The 1, 2, 3 is the smaller of the list. When the default is passed, it gets 100. And again in the last, it is 1 is that minimum. The string 1 is minimum. So this is the min function. Now we will look at next. So next is an iterator related function. So suppose you have an iterator which you can get by calling iter function on an iterable like a list or dictionary, iterable sequence or collection like tuple or dictionary. The tuple is a sequence while dictionary is a collection. So what it does is it retrieves the next item from the iterator by calling its next method. If default is given, it is returned if the iterator is exhausted, otherwise the stop iteration is raised. Now let's try to do it. Okay, so for example, if you want to see that what iter function does is, I showed it in the previous video. Suppose we want to get iterator because we need the iterator here to call the next. So iter takes an iterable. Okay, that is the most common use of an iterator. Suppose we take a list is equal to 3 and we get I as iter and put L in there. So this will return an iterator, and then we call next on that, next on I. Let's see if it works. All right. Okay. So again, unterminated. All right. This is so print. No, it did not print anything. Okay. This got comment. See, so it prints 1. Now what happens if we do it twice? It should print 2 and 3. And if we do one more time, then the default should be returned. Okay, but we are not returning any default. So what it will do is it will raise an exception stop iteration. Let's see this. It should generate an exception stop iteration. So yeah, it does generate stop iteration exception, and otherwise it returns 1, 2, 3. So if you want to supply a default, you can supply, say, for example, 0. Then it should return 0. Yep, returns 0. That's how the iter function and next functions work. Okay, so we comment this out. Now we come to the object function. Object function is the parent class or base class of all other classes in Python, and it has the methods. It is a featureless object, but it has the methods which all other classes will have. So it is important that we see what methods object function has. For the sake of it, we see that. So the functions are default, directory, equality, format, greater than or equal to get attribute, get state for pickle and all, greater than, hash, init is the constructor, less than or equal to, less than, not equal to, reduce is for pickle, reduce, exclusive, rep, set attribute, size of str, and so on. So these are the common functions which every class in Python will have, because object has those. All right. So now we look at octal function. So octal is much like hexadecimal, and as we have learned that hexadecimal converts any integer into hexadecimal representation, octal will convert the numbers into octal representation. For example, oct of 8 would be 10. So the way we formatted the hexadecimal numbers, similarly we have formatted the octal numbers here. So let's see this in action. We have already seen this, but yeah. So 8 becomes 10, and minus 56 becomes 70. So in general, octal function when invoked will print 0 as a prefix, but you can skip this by passing %of or the formatter to O only without hash. If you use the format specifier as #O, then it will print the 0O. Right? So 10 has been printed as 12 in last 3 arrangements. Now we come to a very important function that is called open. Open is used to open a file for reading or writing. Okay? So what it does, this function, is it takes several arguments. It takes file, mode, buffering, encoding, errors, new line, close FD, opener. So let's go through the properties one by one. So it opens a file and returns a corresponding file object. If the file cannot be opened, an OS error is raised. See reading and writing files for more examples on how to use this function. So this is an entirely different section on how to read and write files. So we will not go there right now. Later on we will see. Now what is file? File is a path-like object. It is typically the path on the operating system, the path of the file where it resides, giving the path name absolute relative to the current working directory of the file to be opened, or an integer file descriptor of the file to be wrapped. The question is, if you don't know what a file descriptor is, so let me open the man page of Linux. So this is the base. This is the system call in C which Linux kernel gives us. It takes a path name, it takes flags and mode, and returns an integer. So on successful opening of a file, this integer would be a positive number. Okay? So this number is called a file descriptor. That is the file descriptor we are talking about. Okay. If a file descriptor is given, it is closed when the return IO object is closed, unless close FD is set to false. So this is the close FD. The default value is true. So if you set it to false, then the return IO object will not be closed. Okay. When the file descriptor is given and file descriptor is closed. The second argument is mode. The default is R. So mode can take several characters. There are several characters which describe the mode here. So mode can be R, W, X, A, B, T, and plus. R means open for reading, W means open for writing, but it deletes all the content in the file, which is right now there. X is the exclusive creation. So it fails if the file already exists. A is for writing and appending to the file if it exists. B is binary mode, useful for binary files. T is text mode, useful for text files. Okay, and plus open for reading and writing. All right. So suppose you want to open, read, and write, then you can simply say R plus. Okay, or you can say W plus. Both will have the same effect. Okay, A plus does not make sense because you are in any case reading and writing both. Binary mode is useful for binary files, as I said. W is useful for creating new files. Now buffering, the default value of buffering is -1. So in general, it is not a good idea to touch this buffering, because the default value of buffering will make sure the OS handles the buffering and caching of the pages. In general, we don't use buffering, but for the sake of completeness, we will discuss it here. So it is an optional integer and used to set the buffering policy. If it is set to 0, buffering will be completely off. Now this is allowed only in binary mode. 1 is used to select line buffering. Is usable only when writing in text mode. An integer greater than 1 to indicate the size in bytes of a fixed size chunk buffer. Note that specifying a buffer size this way applies for binary buffer IO, but text IO wrapper, that is the files open with mode R+, would have another buffering. Disable buffering in text IO wrapper. Consider using the write through flag for IO text IO wrapper.reconfigure. When no buffering argument is put in, the default buffering policy works as follows. Okay. So binary files are buffered in fixed size chunks. The size of the buffer is chosen using a heuristic trying to determine the underlying device's block size. So here the important thing is, what is a block size? So when you partition a hard disk, what happens is you have to create a file system, and when you are creating the file system, you can configure its block size, which is typically 4 kilobyte or 8 kilobyte. So what does this mean is, even if you write a file of 1 byte, it will occupy an entire block of 8 kilobyte. So large block size are good for file system which will contain huge files like databases and all. But in general, 4 kilobyte is quite enough, which is good for smaller files like typical day-to-day work. And falling back on IO.default buffer size. On many systems, the buffer will typically be 4K or 8K long. Okay. Interactive text files for which is atty returns true. Now this is something I cannot describe just like that, because it requires the knowledge of terminal interfaces and all, which we have not discussed, and discussing that would be out of scope right now. So later we will discuss this. Okay. Now the encoding is platform dependent. Okay, so the default encoding is whatever local.get encoding returns. But any text encoding supported by Python can be used. See the codecs module for the list of supported encodings. So in general, you should not worry about this at all. If you are using English, then typically ASCII encoding is enough. But if you are not using English, then encoding of UTF-8 is will satisfy almost all the use cases, because predominantly the entire internet works on UTF-8. So it's either ASCII or UTF-8. If you pick one of those, you are safe in this case. If you want to be on the safer side, just use UTF-8 for. Now we come to errors. So errors is an optional string that specify how encoding and decoding errors are to be handled. This cannot be used in binary mode. A variety of standard error handlers are available listed under error handlers, though any error handling name that has been registered with codex.registered error is also valid. The standard names include strict. Strict will raise a value error exception if there is an encoding error. the default value of none has the same effect. So if encoding is if errors is none, then the default let's see the default value of error. So default is none. By default, the errors mode is strict. That is, it will raise a value exception if there is an encoding error. Ignore me will mean the ignore the errors. Okay, but it gives a warning also that if there are encoding errors, then there can be data loss. Replace will cause a replacement marker such as question marks. Suppose you are putting a Unicode character in an ASCII file and you use replace. A replacement marker like question mark will be inserted where there will be the Unicode character. Surrogate escape will represent any incorrect bytes as low surrogate code units ranging from U plus DC80 to U plus DCFF. If you remember, I don't know if you watch my Rust videos or not, so these are surrogate Unicode code points. We have discussed it in brief in my Rust videos. These surrogate code units will then be turned back into the same bytes when the surrogate escape handler is used when writing data. This is useful for processing files in an unknown encoding. XML char ref replace is only supported when writing to a file. Characters not supported by the encoding are replaced with appropriate XML character reference #NNN. Backslash replaces malformed data by Python's backslash escape sequences. We have studied escape sequences in both the Python and the C programming video. Also only supported when writing replaced supporting and character with \n and the code point value of the escape sequences. Now we have discussed errors, encoding, buffering mode. Now we discuss the new line. So in general, you will handle two kinds of new line. One is the Windows style, another is Unix. Unix style is \n and Windows style is \r/n. So how does it work is, so when you read from the stream, if new line is none, universal new lines mode is enabled. Lines in the input can end in \n, \r or \n. And these are translated into \n before being returned to the caller. If it is empty, universal new lines mode is enabled, but lines ending are returned to the caller under untranslated. If it has any of the other legal values, input lines are only terminated by the given string and the line ending is returned to the caller translated. When writing output to the stream, if new line is none, any \n character written are translated to the system default line separator, os.line separator. So you can use this to define the line separator. If new line is empty or \n, no translation takes place. If new line is any of the other legal values, any \n characters written are translated to the given string. So this describes the whole behavior of a new line argument. Now close FD we have already seen when we were discussing the file descriptor picture. Custom opener, the last argument is an opener argument. A custom opener can be used by passing a callable as opener. The underlying file descriptor for the file object is then obtained by calling opener with file flags. Opener must return an open file descriptor. Passing os.opener as os.open as opener results in functionality similar to passing none. Now note that the newly created file is non-inheritable. That is, if a class creates it, then it will not be accessible in the inherited file. There is one example here that we open the current folder as read only, okay, and then we have function opener which take paths and flags, okay, and it does osfd path flags and it takes the directory file descriptor as directory file descriptor which we have just obtained. Now we call open function with the file name, write mode, and as opener, apply the custom opener, and then we write the file. Okay, so the way we write to the file is we use print function and we supply file is equal to f. By default it is stdout, and then we close this. So this will create the file spam.txt when we run this file. We run this and let's see, we have spam.txt. So for verification we remove this, we run this again, and we see spam has come or not. So yeah, it's there. So that's how this custom opener works. So with this, we will come to, you can read this section on your own, and more details will come when we will discuss these classes specifically. So with this, we come to the end of this video. The open function was quite big, so I did not include many other more functions. So if you, I hope that you have found this video useful and informative. If so, please subscribe to the channel, like the video, and share. Make use of comment box to speak your mind. I ask for this because I want the video to reach as many as people possible, as well as it motivates a lot to me. It motivates me a lot. So motivation is required, because without motivation we can't proceed in life. So thanks a lot for watching. Enjoy and happy programming.